Ladies and gentlemen, welcome to SQL Server Performance Monitoring and Tuning webcast brought to you by SQLworkshops.com. These webcasts are designed for developers and database administrators. This is our second webcast. We will initially take a look at parallel query execution. Then we will move on to the topic that we set aside in the last webcast, where I mentioned the possibility of our query to misbehave. Then we will return to parallel query execution topic again. If you have not seen our first webcast, we recommend you to download the webcast from SQLworkshops.com and watch it first. We changed the webcast format slightly. It is still technical, but in a discussion style. My name is Ramesh Mayappan, and I will be presenting this webcast. I will recall some conversation with Mr. JLR, which will be in a discussion format. When I deliver a workshop or present a session in a user group meeting or conference, I strictly deliver technical content. For example, you can see that in my SQL Bits session recordings. But in these free webcasts, we include some side discussions that are not technical. This is our business decision. Let me explain you how SQL Server executes a query in parallel. First, let's see how a query executes serially, single-threaded using single CPU core. Let's set max degree of parallelism to 1. There is a possibility to change the max degree of parallelism at server level by right-clicking Properties, Advanced, and changing the configuration parameter max degree of parallelism to 1 or changing it at the query level. For our example, let's change it at the query level by introducing the option max DOP 1. Let's execute this query. This query will use single CPU core because we set max degree of parallelism parameter to 1. The query took 6.9 seconds. The query took similar amount of CPU, 6.9 seconds. Let's execute this query in parallel with max degree of parallelism parameter set to 0. Since my server has single CPU with 4 cores, this query will use all the 4 CPU cores. Let's execute the query. The query took 1.7 seconds to complete, the elapsed time, the duration. The query took similar amount of CPU, 6.9 seconds. Let's go to the calculator. Let's type in the original execution time and divide by 4 since we have 4 CPU cores, and the query should take 1.7 seconds, and the query took 1.7 seconds. So the query scales very well. Let's set max degree of parallelism parameter to 2, so this query is limited to using 2 CPU cores. Let's execute the query. The query took similar amount of CPU time, 6.8 seconds. The elapsed time is 3.4, which is double compared to executing this query with 4 CPU cores. This query scales very well with additional CPU cores. Let's take a closer look. Let's execute this query in a loop with while 1 equal to 1 and max degree of parallelism set to 1. So this query uses single CPU core. Let's inspect the activity of our session 61. Let's open a new query window. Let's select status and wait type from sysdm exec request for our session ID 61. Let's execute the query. There you see status is running and wait type is null. This shows the query is using CPU and waiting for nothing. Let's inspect the task information by selecting task state, execution context ID, parent task address from sysdm OS tasks for our session. There you see task state is running, which means this query is using CPU. Execution context ID is 0 and parent task address is null. We will talk about execution context ID and parent task address in a minute. Let's also select from sysdm OS waiting tasks to see if our session is waiting for anything. No, our session is not waiting for anything. Let's stop our query. Let's execute this query in a loop, but with max DOP set to 0, which means this query now will use all the 4 CPU cores. Let's inspect the activity of session 61 again. Let's select the task information. Our query has 5 tasks. The task with execution context ID 0 is the parent task. Its parent task address is null. There are 4 child tasks. With execution context ID 3, 4, 1 and 2, the task state is running or runnable. This means the tasks are using CPU or waiting for CPU. Every task as a thread. In this case, every child task as a thread running on different CPU cores, making this query scale well. The task with execution context ID 0 is also known as the coordinator. In this case, it has not much work to do. It has to collect the results from the child tasks and send it to the user. So its state is mostly suspended. It is waiting for the child tasks to complete. Let's select wait type execution context ID blocking execution context ID from sysdm OS waiting tasks. There you see our parent task with execution context ID 0 is waiting for child tasks with execution context ID 3, 1, 2 and 4, and the wait type is CX packet. Let's select status and wait type from dm exec requests for our session. There you see the status is suspended and the wait type is CX packet. Our query, the request, the coordinator is waiting for all child tasks to complete with wait type CX packet. Irrespective of CX packet waits, the query is 4 times faster using all 4 CPU cores. This query scales very well. Mr. JLR told me he noticed advice in the internet that states CX packet waits are a direct result of delays associated with inefficiencies of parallel processing. I told Mr. JLR that is a wrong advice, and I will demonstrate some more examples to better understand CX packet waits in a moment. Let me tell you, there are cases where parallel queries are efficient and there are cases where parallel queries are inefficient. For example, one day I was called in to address a customer performance issue. There the parallel query execution was not efficient like we want it to be. I turned it off by setting the max degree of parallelism parameter to 1, and the customer reported satisfactory performance that evening. In this case, the customer was a referral from Microsoft Norway, but I had direct contract with the customer working off-site. There was another customer where the parallel queries were very efficient, like the ones we just saw. They were searching names with wildcard character, which happens quite often at customers, like person Sonia person Brian person. I don't know why some customers have to put the wildcard character before and after the name, but many customers do, and sometimes we have to just live with their wish. The customer's major wait type was CX packet. No IO issues, no locking issues. They had a database for employee time reporting that was pretty much smaller than the RAM, the memory they had, mainly inserts and select with no lock hints. In that case, if we switch off parallelism by setting max degree of parallelism parameter to 1, the customer will not be happy. The queries will run 8 times slower since the query will not use all the 8 CPUs the customer had, instead will use only 1 CPU. Mr. JLR asked me to search the internet with the keyword CX packet parallel delays. He asked me to click on the first link, which is the MSDN website, and to scroll few pages down. There he showed me the speaker stated in a session hosted during past community summit, CX packet waits are a direct result of delays associated with inefficiencies of parallel processing. Mr. JLR tells me, you know what I think is, these sessions are not reviewed for technical correctness. You know, these are the so-called spotlight sessions. They are presented by speakers who are the industry experts, community leaders, the best of the best, the cream of the cream. And I think there is no one to review these spotlight sessions for technical correctness. If at all, the spotlight session speakers are the one who might review the non-spotlight session content. I asked Mr. JLR to cut it out. Everyone makes mistakes, no exception. I make mistake. I would like to take this opportunity to ask the viewers, if you notice a mistake in my webcast, please send me an email and I will communicate that to those who are on my mailing list. I think as an instructor, it is important for me to take the responsibility to recognize the mistakes and to correct them on a timely manner. I know you want to see an example. Let me show you an example. Let's open a new query window and let's execute this query in a loop for 2 times. First, I will reset the DMOS wait stats with dbcc SQL perf command. All the commands I use in my webcasts and in my workshops are documented. This dbcc command is documented in SQL Server Books Online. I just want to make it clear that I do not promote using undocumented commands. They give you false confidence and really useless in a production server as you cannot use them. Microsoft will not support these commands, and if it breaks anything, you are on your own. Let's execute this query with max degree of parallelism set to 1, so this query is limited to using 1 CPU core. Finally, we will select from DMOS wait stats the weights related to CX packet. Let's execute this query 2 times in a loop. When we executed the query single time, the query took around 6.9 seconds to complete. So when we execute the query in a loop for 2 times, it will take around 13 seconds. So the query took around 13 seconds, 13 point something. Management Studio will always round it up to the seconds. So you see 13, and CX packet weights are 0. Since there was no parent task, a coordinator waiting on CX packet, the CX packet weights are 0. Now let's change the max degree of parallelism to 0, so this query can use all the 4 CPU cores available in my computer. Let's execute this query. This query used to execute in 1.7 seconds, which is 3.4 seconds when we execute it twice. Management Studio shows you 3 seconds, and if you see, CX packet weights are not 0 anymore. They are high, irrespective how you look at them. As a standalone number, which is 3.4 seconds, or as an average number, that is wait time milliseconds divided by waiting task count. They are high. Think about it. If you execute this query, part of a report or part of a job, thousands of times, the CX packet wait time will be very high. Just looking at the high CX packet wait time, do not start decreasing your max degree of parallelism parameter. Right now, this query used 4 CPU cores. If you reduce the max degree of parallelism to 2 and execute this query will take longer to complete because this query is limited to use 2 CPU cores. And there you see the query took 6 seconds to complete. Actually 6.8. Management Studio shows you 6 seconds to complete. And the CX packet weight in fact went higher. By reducing the max degree of parallelism, you increased the CX packet wait time. By changing the max degree of parallelism parameter from 0, which is equivalent to 4 in my computer, to 2, we increased the CX packet wait time and we made the query run slower. By setting max degree of parallelism parameter to 1, we eliminated the CX packet weights, but we slowed the performance of this query by 4 times. By showing that high CX packet weights in this case are not, let me stress, not a direct result of delays associated with inefficiencies of parallel processing, I prove the advice is wrong. If you go back to the website, few lines above, you will see a statement from SQL Server Customer Advisory Team, SQL CAT team, clarifying it is misleading to jump to the conclusion that CX packet weight are a bad thing in general. So let me tell you, I am not alone in correcting these mistakes. CX packet weights alone cannot help one identify inefficient parallel queries. You need to take a look at the bigger picture and not just at CX packet weights alone. You know what I am worried the most? If someone, a consultant or a DBA makes a mistake by reducing the max degree of parallelism parameter without understanding the bigger picture due to high CX packet weights, and if that affects the performance, the customer might not be happy. If the customer is knowledgeable, they will fire the consultant. If their DBA is very confident that CX packet waits are direct result of delays associated with inefficiencies of parallel processing and reduces the max degree of parallelism parameter, if his or her manager has no technical background, then the management will think the performance problem is in the product. In this case, in SQL Server, and the customer might migrate to Oracle or DB2. We have to be careful here. We have to take responsibility in educating the consultants, developers, and DBAs in the right way. Let me tell you something. Please don't think I am one-sided supporting the SQL Server developers at Microsoft since I worked with them in the past. I know these developers. They are working hard every day to make and keep SQL Server the best platform among the competition. I don't think these developers will invent a wait type like CX packet to introduce inefficiencies in parallel processing. Why should they do that? There is no logic behind it. I know many of you have questions on how to determine if a parallel query is efficient or not. Yes, it is a very important question. I plan to address this later in this webcast and in future webcasts. We are going to allow prioritized access to future webcasts. Don't forget to send your email address for notification. Let's move on to the planned next topic before we return to parallel query execution topic again, the query that could misbehave. Let's execute a similar query from our last webcast. For those viewers who haven't seen our last webcast, we recommend that you download the webcast from SQLworkshops.com and watch it first before continuing with this part of the webcast to have continuity. This query selects from tab 7 with predicate C1 between 100,000 and 400,000 ordered by C2. With max DOP1, we limit this query to use single CPU core, and instead of character 2000 like in the last webcast, we use character 200. Let me execute the query. The query takes 2.9 seconds. Let's execute the query again. The query is slow because the sort spills to TempDB. Let's introduce the workaround from the last webcast. Instead of character 200 and simply C3, we say varchar 450 and we say convert C3 to varchar 450. Let's execute the query. The query is fast. Does not take 2.9 seconds, instead takes 0.5 seconds. You know, our goal is to increase the memory. Instead of changing the data type to varchar of higher size, you can also tell the optimizer to allocate enough memory to sort a larger amount of rows. Let me show you an example. In this query, again we select from table tab 7, where C1 between variable, we do not give predicate as a constant. Instead of 100,000 and 400,000, we give a variable I and j. Here I declare and I initialize the variable to 100,000 and 400,000. I also include a hint to the optimizer that says optimize for predicate value 100,000 and 400,000. Let's execute this query. The query is slow. Again takes 2.9 seconds. SQL Server spilled the sort to TempDB. Let's include the execution plan and let's execute the query again. Let's inspect the execution plan. Let's move the cursor on top of the sort operator like we did in the previous webcast. There you see estimated row size is 215 bytes, estimated number of rows 300,000. The amount of memory allocated for sort is not enough. So instead of changing the data type to varchar, let's tell the optimizer we have rows between 100,000 and 460,000. Let's execute this query. The query is fast. Takes again 0.5 seconds. Let's execute the query again. The query is fast. Instead of changing the data type, by simply telling the optimizer we have more rows to sort, we made the optimizer allocate more memory and we avoided the spill to tame the bee. You have to be careful here. The optimizer is looking at the statistics and estimates the number of rows and not from your predicate range. Let's change this query to select rows between 500,000 and 800,000. Let's inspect the execution plan. There you see the sort operator estimates 360,000 rows, so SQL Server has enough memories to sort our 300,000 rows. Let's delete some rows from this table. Let's delete rows between 400,000 and 500,000 and let's update the statistics. Let's execute our query again. The query is not fast. It is not taking less than 1 second. It is taking 3 seconds, 3.033 seconds. Let's execute the query again. The query takes 3.037 seconds. Let's inspect the execution plan. There you see under sort operator, the SQL Server estimated around 300,000 rows, 297,509 rows instead of 360,000 rows. So optimizer did not give enough memory for our query for the sort to happen in memory. The reason is the optimizer looked at the statistics and there were no rows between 400,000 and 500,000, so it estimated nearly 300,000 rows for this range. You can use this concept over queries that are using date-time data type. You can tell the optimizer always to optimize for 1 month date range, irrespective the range the user selects. You can give a sample date range. But the danger is if that range is eventually archived and not in your production database anymore, the optimizer will estimate 1 row and the query will perform worse. Let me show you an example. Let's delete rows less than 500,000 and let's update the statistics with full scan. Let's execute our query again. This query will be very slow because SQL Server will estimate 1 row because there are no rows between this range. 100,000 and 460,000 in the database because we deleted all the rows less than 500,000. Let's check on the query in a minute. Meanwhile, I want to share a question Mr. JLR asked. He asked me how he can develop deep SQL Server knowledge. I told him I will not take this opportunity to promote my 3-day level 400 performance monitoring and tuning workshop. Instead, I will give general guidelines. You know, my first recommendation would be that you read selective SQL Server books from Microsoft Press. Anyone who is interested can send me an email and I will send you my current book recommendations. Don't forget to mention if you are a developer or a DBA. If you read these books and don't understand certain concepts, don't get stuck on that concept or that page. Mark it, skip it, and continue reading. Later, ask your colleague or send these authors an email asking them for more explanation. Until you cover the basics from these books, do not go for expensive trainings or workshops, including mine, or paid conferences. It's a waste of time and money. Once you read these books and have some basic concepts, you can think about going to some trainings or workshops. In case you go to a training or a workshop, tell the instructor that you have already read these books and you don't want a repeat of that in the training. If there are overlaps, ask the instructor how much percentage overlap is there so you can decide for yourself if it is worth attending. Let's see what happened to our query. The query took 14 seconds to complete. Let's inspect the execution plan. There you see the sort operator estimated 1 row instead of 300,000 rows based on our optimized for values. Since we deleted these rows from the database. The penalty with a varchar workaround is you pay for data conversion every time, but you don't run into this risk.